Hi to all. In the previous classes, we discussed about the basic concepts about electromagnetics, that is magnetostatics chapter. We studied Biot-Savart's law, Ampere circuit law, and the concept of magnetic flux density. Now we go for magnetic force and scalar and vector magnetic potential in unit 4. That is the end of the third unit is magnetic force and magnetic field inductance due to a current carrying conductor. And all this force on a moving point charge, the force which created by a point charge which is moving, those we'll discuss now. Let us go for force on a moving point charge. What is the force on the charge whenever it is moving in the conductor? According to Coulomb's law, what we studied previously, the Coulomb's law is the law that relates whenever a electric field E bar exerts a force on static or moving charges. According to Coulomb's law, F equal to Q1 Q2 by 4 pi epsilon naught r square, that is you know that force between 2 point charges. Similarly, according to Coulomb's law, an electric field E bar experiences a force. What is the definition? You know the definition of electric field intensity or force per unit charge, F by Q, force per unit charge is known as electric field intensity. That is the relation you know already. The force per unit charge, the electric field intensity is defined as. How to define electric field intensity we studied in first unit. The electric field intensity E bar equal to F by Q. That from this, when the according to Coulomb's law or the force Fe exerted on electric charge, assume that it is a force Fe. The force Fe exerted on electric charge, Fe equal to, from this Coulomb's law, Fe equal to Q into E bar. By doing cross multiplication, Q into E bar. Therefore, the force can be related with electric field intensity, Fe equal to Q into E. That is, force is the vector, make it as equation 1. Make it as equation 1. How can you say that Fe equal to, Fe is the electric charge, force on electric charge Fe equal to Q into E. How can we relate? Manaku electric field intensity formula telusu. Electric field intensity E bar equal to Fe by Q or F by Q. Force per unit charge is Q. The definition of electric field intensity, suppose oka charge inko charge మీద ఎంత ఫోర్స్ క్రియేట్ చేస్తుంది. సపోజ్ ఒక ఛార్జ్ అంటే ఫస్ట్ యూనిట్లో చదివాం. ఈ బార్ ఈక్వల్ టు అంటే ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఈక్వల్ టు ఫోర్స్ బై ఫోర్స్ డివైడెడ్ బై ఛార్జ్ ఆర్ ఫోర్స్ పర్ యూనిట్ ఛార్జ్. ఇక్కడ ఫోర్స్ దేని మీద ఉంటుంది? ఒక ఛార్జ్ మీద ఉంటుంది. కాబట్టి అజ్యూమ్ దట్ ఎలక్ట్రిక్ ఫీల్డ్ ఫోర్స్ ఆన్ ఏ పాజిటివ్ ఛార్జ్, నెగిటివ్ ఛార్జ్ ఆర్ పాజిటివ్ ఛార్జ్, దట్ ఈస్ Fe బై క్యూ. అంటే మనకు ఈ ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ నుంచి ఈ ఈక్వేషన్ వచ్చింది. ఫోర్స్ ఆన్ ఏ ఛార్జ్ ఈస్ Fe ఈక్వల్ టు క్యూ ఇంటూ ఈ. వి ఒబ్టైన్ దిస్ ఈక్వేషన్. ఈ ఫోర్స్ ఛార్జ్ మీద ఎగ్జర్ట్ అయింది కదా, Fe ఈక్వల్ టు క్యూఈ. దేర్ఫోర్ దిస్ ఫోర్స్ ఆల్సో కాల్డ్ రెఫర్డ్ యాజ్ Fe ఈజ్ నథింగ్ బట్ ఎలక్ట్రిక్ ఫోర్స్. ద Fe ఈజ్ కాల్డ్ యాజ్ ఎలక్ట్రిక్ ఫోర్స్. ఎలక్ట్రిక్ ఫోర్స్ ఇట్ ఈస్ Fe. The electric force Fe is given by Q into E. The product of electric field intensity and the charge is known as Fe equal to Q into E. Make it as equation 1. Now consider ఆ ఛార్జ్నే తీసుకెళ్ళి స్టడీ మ్యాగ్నెటిక్ ఫీల్డ్లో పెట్టాం. ఒక ఎలక్ట్రిక్ ఫీల్డ్లో ఉంటే ఇది ఎలక్ట్రిక్ ఫీల్డ్ లైన్స్ ఇలా పాస్ అవుతూ ఉంటే ఎలక్ట్రిక్ ఫ్లక్స్ లైన్స్, అప్పుడు వచ్చే ఫోర్స్ ఎలక్ట్రిక్ ఫోర్స్ ఆన్ ఛార్జ్. ఒక ఛార్జ్ మీద ఎంత ఎలక్ట్రిక్ ఫీల్డ్, సపోజ్ ఎలక్ట్రిక్ ఫీల్డ్ ఫ్లక్స్ లైన్స్ ఇలా పాస్ అవుతుంటే ఇక్కడ ఒక ఛార్జ్ ఉంటే వాట్ ఈస్ ద ఫోర్స్ ఆన్ దట్ ఛార్జ్? Q ఈజ్ ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ ఈజ్ గివెన్ బై దిస్ ఫార్ములా Fe బై Q. మనకు ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీ అంటే మనకు తెలుసు కదా, యూనిట్ 1లో చదివాం. ఈ ఛార్జ్ మీద ఎంత ఫోర్స్ క్రియేట్ చేస్తుంది ఈ మ్యాగ్నెటిక్ ఫీల్డ్? Fe ఈక్వల్ టు Q ఇంటూ E. That may be electrical force. Because of electric field, only electrical force will be created on that charge. Now we go for the same charge. ఇదే ఛార్జ్ని తీసుకెళ్ళి మ్యాగ్నెటిక్ ఫీల్డ్లో పెట్టామనుకోండి. Phi magnetic field is B bar or H bar. B bar or H bar. Magnetic field in the sense we can represent హెచ్ బార్ మ్యాగ్నెటిక్ ఫీల్డ్ ఇంటెన్సిటీ ఎలక్ట్రిక్ ఫీల్డ్ ఇంటెన్సిటీతో పెట్టినప్పుడు ఈ విధంగా వచ్చింది. సపోజ్ ఇఫ్ ద చార్జ్ ఈజ్ ప్లేస్డ్ ఇన్ మ్యాగ్నెటిక్ ఫీల్డ్, ఇఫ్ ద చార్జ్ ఈజ్ ప్లేస్డ్ ఇన్ మ్యాగ్నెటిక్ ఫీల్డ్, ఒక చార్జ్ ఇక్కడ మ్యాగ్నెటిక్ ఫీల్డ్లో పెట్టామంటే అప్పుడు ఏమవుతుంది, ఫోర్స్ విల్ బి ఎగ్జర్టెడ్. ఇట్ ఎక్స్పీరియన్సెస్ ఏ ఫోర్స్ ఓన్లీ ఇఫ్ ఇట్ ఈస్ మూవింగ్. మనకు ఒక ఛార్జ్ మూవ్ అవుతూ ఉన్నప్పుడు మాత్రమే ఫోర్స్ ఉంది. కరెంట్ క్యారింగ్ కండక్టర్ ఎక్స్పీరియన్సెస్ ఏ ఫోర్స్ ఇంటూ డిస్టెన్స్. అంటే ఒక కండక్టర్ని మూవ్ చేసినప్పుడు కరెంట్ క్యారింగ్ కండక్టర్ వెన్ ఎవర్ ఛార్జ్ ఈజ్ మూవింగ్ ఏ ఫోర్స్ విల్ బి క్రియేటెడ్. అదే ప్రిన్సిపల్ మీద పనిచేస్తుంది కదా మోటార్. ఇట్ ఎక్స్పీరియన్సెస్ ఎ ఫోర్స్ ఓన్లీ వెన్ ద ఛార్జ్ ఈజ్ మూవింగ్. ఒక ఛార్జ్ మూవ్ అవుతున్నప్పుడు కండక్టర్లో ఫోర్స్ విల్ బి క్రియేటెడ్. సిమిలర్లీ ఒక ఛార్జ్ని తీసుకెళ్ళి మ్యాగ్నెటిక్ ఫీల్డ్ హెచ్ బార్లో పెట్టామనుకోండి, అప్పుడేమవుతుంది, ఫోర్స్ క్రియేట్ అవుతుంది. ఆ ఫోర్స్ని మనం మ్యాగ్నెటిక్ ఫోర్స్ అంటాం. లెట్ us write that magnetic force. The magnetic force Fm exerted, assume that Fe is electric force, Fm is magnetic force, M suffix for Fm is magnetic force. Let Fm be the magnetic force exerted on a charge Q when it is moving with a velocity v bar. The charge is moving with velocity v bar. Assume that charge is moving with velocity v bar. Then the magnetic force Fm exerted on a charge. Then the magnetic force exerted on a moving charge Q with a velocity v. Assume that v is the velocity of the charge moving in a conductor or anywhere in a steady magnetic field b bar. Assume that b bar is the magnetic field. In this b bar a charge moving charge is placed, that is q. q is the charge. ఛార్జ్ని తీసుకెళ్ళి ఒక మ్యాగ్నెటిక్ ఫీల్డ్లో ప్రొవైడ్ చేసామంటే అప్పుడు మ్యాగ్నెటిక్ ఫోర్స్ Fm ఈజ్ గివెన్ బై q ఇంటూ వెలాసిటీ ఆఫ్ ఛార్జ్ క్రాస్ ప్రోడక్ట్ ఆఫ్ b ఇంటూ q ఇంటూ v ఇంటూ b, that is Newtons. This is the equation 1. Previously we assumed that it is equation 2. Assume that it is equation 2. Now consider the charge is placed in steady magnetic field. It experiences a force only if it is moving. Then magnetic force Fm exerted on that charge, moving charge మీద ఎంత ఫోర్స్ క్రియేట్ అవుతుందంటే ద వెలాసిటీ, ఇంత వెలాసిటీ వెళ్తూ ఉంటుంది ఇది మూవింగ్ ఛార్జ్, v వెలాసిటీ q ఇంటూ v ఇంటూ b న్యూటన్స్. ద magnitude of force Fm is directly proportional to magnitudes of q and v, charge మరియు velocity of the charge and magnetic flux density and also the sign of the angle between them. If you remove this cross product, qv b sin theta, the angle is v and b. What is the angle? The velocity of the charge and flux density. What is the angle? If the charge is moving in this direction, it is the theta we have to assume. The direction of magnetic field is perpendicular to the plane containing v bar and b bar both. You can see the diagram here. Again you can see. Assume that this is the one plane containing velocity of charge and flux density, all will be there. Assume that a charge q, it is the charge q is located here. Then it is moving with a velocity v bar. Assume that v bar and flux density b bar. It is also maybe h bar also you can consider, but we are in place of mu h we have to write in place of b bar. Then the force exerted on this charge is Fm is the force right angle to the both. An is the unit vector for this force. Assume that it is the theta, the product of v and b and the cosine or sine of the angle between b and v. That is Fm equal to q into v cross b. We can write like this. అంటే ఈ రెండు ప్రోడక్ట్ v అండ్ b క్రాస్ ప్రోడక్ట్ ఆర్ సైన్ యాంగిల్ తీసుకోలేదు. క్రాస్ ప్రోడక్ట్ ఎలా రిమూవ్ చేస్తాం? సైన్ ఆఫ్ ద యాంగిల్, 2 వెక్టర్స్ ఇంటూ సైన్ థీటా గివ్స్ క్రాస్ ప్రోడక్ట్ కదా. This is the plane containing vectors V and B. Therefore, magnetic force Fm equal to Q into V cross B. This is the magnetic force on moving charge. Moving charge మీద ఎంత magnetic force ఉంటుంది? That is known as magnetic force on moving charge. This is the angle between B and V. అదే మనకు ఒక ఈక్వేషన్ 1 నుంచి చూస్తే, సపోజ్ ఈక్వేషన్ 1 ఏంది? FE ఈక్వల్ టు ఎలక్ట్రిక్ ఫోర్స్ ఈక్వల్ టు Q ఇంటూ A. ఇట్ ఈస్ ఇండిపెండెంట్ ఆఫ్ FE ఈస్ ఇండిపెండెంట్ ఆఫ్ సైన్ ఆఫ్ ద యాంగిల్ ఆర్ వెలాసిటీ ఆల్సో. వెలాసిటీ విల్ నాట్ కమ్. ఎలక్ట్రిక్ ఫోర్స్ దగ్గర వెలాసిటీ రాదు. ఛార్జ్ స్టాటిక్గా ఉన్న డైనమిక్గా ఉన్న ఎలక్ట్రికల్ ఫోర్స్ ఉంటుంది. FE ఈక్వల్ టు Q ఇంటూ E. ఫ్రమ్ దిస్ ఈక్వేషన్ వీ కెన్ సే దట్ FE electric force is independent of velocity. Independent of velocity. It is not depends on, from equation 1. In other words, electric force exerted on the moving charge by the electric field is independent of the direction of the charge is moving. The equation 2 చూసారు అనుకోండి, FM magnetic force. FM depends on velocity and flux density. Fm can perform the work on a moving charge as it is right angle to the direction of the charge. F dot dl equal to 0. If the right angle is there, sin 90 will be maximum. It will be, on the other hand, we can say that magnetic force Fm depends on the velocity of the moving charge. Previously, it is not depends on moving charge. The total force on moving charge in the presence of electric field, magnetic field రెండు ఉన్నాయి అనుకోండి. ఎలక్ట్రిక్ ఫీల్డ్ E బార్ అండ్ మ్యాగ్నెటిక్ ఫీల్డ్ B బార్ రెండు ఒకే చోట ఒకే ఛార్జ్ మీద యాక్ట్ అయ్యాయి అనుకోండి. ద నెట్ ఫోర్స్, ద టోటల్ ఫోర్స్ ఆన్ మూవింగ్ ఛార్జ్ ఇన్ ద presence of both electric and magnetic field, the total force on moving charge in the presence of electric field and magnetic field, in the presence of these two forces we have to add equation 1 and 2. It is the equation 2, or simply it is also equation 2. By adding 1 and 2, total force on this charge can be obtained. Therefore, the total force F on the moving charge is given by F equal to FE plus FM. FE plus FM. If you add equations 1 and 2, then common term is Q. The common term is Q in both equations. Q into E plus V cross B. V bar and B bar. It is the total force on moving charge. The above equation is called Lorentz force equation. This equation, make it as equation number 3. The equation 3 may be called it as Lorentz force equation. What is this? Lorentz force equation. This equation may be called as Lorentz force equation. Lorentz force equation. This equation is called Lorentz force equation. The above equation called, this equation 3 called Lorentz force equation, which relates the mechanical force to the electrical force. Mechanical force to the electrical force. If the mass of the charge is m, then we can write F equal to ma. If the mass of the charge is m, if the charge of electron may be considered as the mass of the electron, F equal to ma we can write. That equal to m into acceleration, it is m into dv by dt. We can write dv by dt. Therefore, F equal to ma, that equal to m into dv by dt. We can write dv by dt. In place of v, we can substitute that equal to q into E plus V cross B. V cross B newtons. This is the newtons. This is the Lorentz force equation. F equal to ma equal to m dv by dt, or F equal to QE plus V cross B. F equal to Lorentz force equation. F equal to Q into E plus V cross B, where V is velocity of electron or charge, and B is the flux density, E is the electric field intensity. This is the force equation, Lorentz force equation. We can find the force Fm or Fe by doing some numerical problem. The numerical problem related to Lorentz force equation, you can see this in one example. A point charge Q is given by minus 1.2 coulombs, has a velocity vector. The velocity is 5ax plus 2ay minus 3az meters per second. Find the magnitude of the force exerted on the charge. If E bar is given as 18ax 5ay minus 10az, B bar is minus 4ax 4ay 3z. Both are present simultaneously. If what is the force from this first equation we have to use, and for the second we have to use second equation. For this we have to use second equation, and finally we are adding both Lorentz force equation, that is third one. Answer is first we are force exerted by E bar, only electrical force Fe equal to QE, that equation 1 we assumed previously. From that Q is minus 1.2 nanocoulombs. The given answer is given data. Q is minus 1.2 minus into Q into E bar. E bar we are multiplying. If you multiply with this E bar and Q we substituted, multiply, then 18 into minus 1.2 minus into minus, it is plus 21.6x plus into minus 6ay plus 12az. It is the force Fe. It is the force, electrical force. This is the answer for this one. The magnitude of force is given by, how to calculate magnitude? Fe equal to square root of 21 here for this square, and we have to multiply 21.6 square minus 6 square plus 12 square, finally 25.4275 newtons. That is the first one. We are applied electrical force formula, that is equation 1 only. If you apply for B bit, the B bar is given as minus 4ax plus 4ay plus 3az. The B bar is given as. For that we have to use Fm, magnetic force. Fm equal to Q into V cross B. This formula we have to use. The velocity also given, the velocity vector also given, V cross B we have to use. The equation 2 what we discussed previously, that we have to use. The magnetic force exerted on B due to both the charges E bar and B bar, that is Lorentz force equation we have to use. Fm equal to Q into V cross B. The magnetic force is given by C bit is Fe plus Fm. First magnetic force we have to calculate, Q into V cross B. Already we studied this equation as 2. Substitute all the values. Vector we substituted V bar and B bar, the cross product, the multiplication of this with 4 into 5, 1.2 into 5 minus 6ax, we are multiplying and doing cross product. The cross product can be done in determinant form. First we written ax, ay, az, and this is B bar, this is V bar, and this row, entire row is B bar. Substituted in determinant form. Finding the determinant, how to find determinant, you know, by doing like this, ax into the product of this and this one, that one we written. Similarly we have to consider different columns and rows. Finally we obtain magnitude of one vector, and magnitude is given by 40. And C bit is the force exerted on charge due to both the fields E bar and B bar. Fe plus Fm we have to add. Equation 1 and 2, that is Lorentz force equation. Q into E plus V cross B, or Q into E plus Q into V cross B. If you add all this, you will get the answer. We have to add all the two. First we substituted the two vectors, Fe vector and Fm vector, magnetic field. After that we added, finally we obtained the magnitude 21.739. By this way we have to apply the Lorentz force equation to get total force. That is the example. Force on a differential current element we have to go. Another one, force on differential current element. Suppose the current element is L length, if you consider dl is the differential length. On this current element, what is the current force? The force exerted on a differential element of charge dq moving in a steady magnetic field is given by df equal to dq into v cross b newtons. dq into v cross b newtons. Previously, the Lorentz force equation we substituted df, f equal to, what is the Lorentz force equation? F equal to q into v cross b. F into q into v cross b, that is the Lorentz force equation. Differential force will be created on differential element. ఒక కండక్టర్ ఎలా ఉంటే ది లెంత్ డిఫరెన్షియల్ ఎలిమెంట్, వాట్ ఈస్ ద ఫోర్స్? డిఎఫ్. ఎఫ్ వి నో, ఎఫ్ ఈక్వల్ టు క్యూవి ఇంటూ వి క్రాస్ బి, క్యూ ఇంటూ వి క్రాస్ బి. ప్రీవియస్లీ లారెన్స్ ఫోర్స్ ఈక్వేషన్. ఫ్రమ్ దట్ ఈక్వేషన్ డిఫరెన్షియల్ ఫోర్స్, ఒక ఫోర్స్ ఈక్వేషన్ మనకు తెలుసు. దిస్ ఈజ్ ద ఫోర్స్ ఆన్ ఏ కరెంట్ ఆర్ ఎనీ చార్జ్. F equal to Q into V cross B. Differential force ఏమవుతుంది? DF equal to DQ into V cross B. DQ into V cross B newtons. Hence we written like this. The current density J bar in terms of velocity of a volume charge density, we can write D bar like this. The current density J bar in terms of velocity of volume charge, J bar equal to rho v into V. J bar we can write the current density. But the differential element of charge can be expressed in terms of volume charge density as dq equal to q equal to rho v dv. You know rho v dv. Q equal to rho v dv. Rho v dv. Therefore dq equal to rho v dv we can write. Substituting the dq, the equation 3 in this equation, you know q equal to rho v dv, total charge will be obtained. The total charge can be written as rho v volume charge density into differential volume into total volume. If you integrate, you can get total charge q. But differential charge ఏమవుతుంది? dq equal to rho v dv and write rho v dv. Equation 3, it is equation 3, we are substituting in this equation 1. Substituting the value of dq in equation 1, df equal to rho v dv. In place of this dq, we substituted rho v dv v cross b. Substituting the value of dq in this equation 1, then we can write rho v dv cross v cross b, we can write in this equation. If you substitute, we can write df as j cross b dv, make it as equation number 4. The force exerted on surface current density. Current density is given by surface. ఒక సర్ఫేస్ మీద కరెంట్ డెన్సిటీ ఉంటే అప్పుడు ఏమవుతుంది? ఫోర్స్ df ఆన్ కరెంట్ డెన్సిటీ వెక్టర్ క్రాస్ ప్రోడక్ట్ ఆఫ్ కరెంట్ డెన్సిటీ and b bar. Similarly, the force exerted on differential current element. The force exerted on differential current element. అంటే చిన్న డిఫరెన్షియల్ సర్ఫేస్ ఏరియా మీద ఎంత ఫోర్స్ ఉంది? df equal to idl cross b, we can write. Because j dv it is idl cross b, we can write j current density as idl and b bar differential force. Hence it is idl cross b. Integrating the equation 4 over the volume, if you integrate the equation 4, df equal to j into j cross b, df equal to j cross b. If you integrate over the volume, then we will get the force F bar equal to volume integral j cross b bar dv. This is the equation 5. The equation 5 is k cross b. Integrating the equation 5 over the closed surface, we will get F equal to surface integral k cross b. What is this? Force on differential current element. Differential current element may be line charge current density, that is dl, differential element. Surface charge also differential surface. Similarly, integrating the equation 6 in a closed path, we got f equal to ideal cross b. So, closed integral ideal cross b. These are the equations related to differential elements. Now, force on straight and long current carrying conductor. Force on straight and long current carrying conductor. Let us go for that. A conductor, long straight carrying conductor. If a conductor is straight, long current is I is the current, and the flux density is B bar in uniform. It is uniform B bar. Along then integrating differential force dF. The equation 6 is dF equal to F bar equal to equation 6. Already we know that equation 6. The equation 6 F equal to ideal cross B. The equation 6 is if the conductor is long current carrying conductor, then one of the equation we have to remember this equation F equal to BIL sin theta ela vachindi. F equal to BIL sin theta. The force మనం బేసిక్స్ అవుతుంటాం కదా మిషన్స్లో కానీ ఫోర్స్ ఎగ్జర్టెడ్ ఆన్ కండక్టర్ F equal to BIL sin theta ఎలా వచ్చిందంటే that is a differential element. The total force is ideal cross B. That is equation 6. Equation 6 is ideal cross B. Net force is integrating that. That is F equal to IL into B. If the L is the length of the conductor, B is the flux density. Force on long current carrying conductor, it is F equal to IL cross B. Therefore, the magnitude of force is given by, if you remove the cross product we have to multiply with sin theta, or if you remove the sin theta we have to do cross product. F equal to BIL sin theta. This is the force on a straight and long current carrying conductor. Long current carrying conductor. For example, if you consider a conductor of length 6 meters along z-axis, it is with a current of 2 amps in a AZ direction, find the force experienced by that conductor if flux density is 0.08 AX Tesla. A force exerted on current carrying conductor in magnetic field is given by F equal to I dl cross B. That is already F equal to BIL sin theta also we can use. If we do the cross product of force, already we know that B bar and I current also given, and dl is length of the conductor is 6 meters. F equal to ideal cross B or F equal to BIL sin theta. That already we know. The same formula we are using here to find the force exerted on the conductor, long conductor. I current is 2 amps, dl is 6 AZ. The conductor length is 6 meters, again 6 AZ into cross product of 0.08, that is flux density is given as 0.08. Now doing the cross product 0.96 AY, AZ cross AX equal to AY, the cross product is. Then for force direction will be AY direction it is. Therefore the force on long current carrying conductor is F equal to 0.96.